All right, Algebra 2, working at lesson 43. We're going to solve systems of linear inequalities. You'll notice really the only difference here between what we've done before and what this is normally, and what we've already done is we've solved systems of linear equations. This is just inequalities. So it's solving systems of linear equations, but with inequality symbols and with inequality graphs. Not a whole lot different. We still graph the line the same way. The only thing that's going to really change here a whole lot is that our graphs are going to include either solid or dotted lines, and they're going to include shading, right? And so we're going to have multiple sets of shading. So we might see where we have overlapping shading results in even darker shading. That even darker shading where our shading crosses is the solution sets to both inequalities. Okay, does that make sense? You've seen it before? I don't know if we've done linear inequalities and graphed them and shown a shading, but we've never put two lines on the graph at the same time and had two sets of shading. Okay? Probably. I mean, a lot of Algebra 2 is just Algebra 1, but a little bit more. Okay? Okay, so a system of linear inequalities is formed by two or more linear inequalities. An ordered pair is a solution of a system if it is a solution of every inequality in the system. So we can have more than two, but you got to have, you got to have at least two in order to have a system. So to graph a linear inequality, and really this is the only page for this information. The rest of it's just working it out and showing it. You first graph that boundary line, so you graph the equation line. You shade whichever half plane needs to be shaded, so whichever side of it is the solution to that linear inequality. And then you graph the other linear inequality, and you shade whatever half plane works for that linear inequality. Okay? If the point is a solution, and you shade that half plane. If the point's not the solution, you shade the other half plane. The graph of the system is the intersection of the graphs of the inequalities in the system. So it's really not terribly complicated. Let me see if I can get over here if there's nothing else in there. All right. Okay, just the one slide. And so we'll look here. Okay. So a lot of these already have our graphs. They say graph, but we don't really need to. All right, so let's look at the first one where it says y is less than negative 3x plus 2. So when I'm looking at negative 3x plus 2, what's the first thing I want to notice about that inequality? And if I wanted to graph it. It's a dotted line. How do you know it's a dotted line? There's no equal to sign. Okay, good. All right, what's the next thing I want to do is I graph just that inequality? Somebody besides Eric. What's that? The what? The slope. Okay, so what do you notice about the slope? It's negative, so it's a line that's going down, but down from where? The beginning point. What is the beginning point? 2. And where is that 2 going to be located? All right, so I would look for 2 on the y-axis, okay? And it says y is less than that line. So if you notice all of these graphs, do they all graph that first line correctly? No, they don't. Which one doesn't graph it correctly? D doesn't. But all the others do, right? And they all include a dotted line, right? Okay? And then if we look at y is greater than or equal to 4x minus 1, well, what do we notice about, what do we know that line is going to look like? Solid line because it has an equal to. What else? It's got a slope of 4, so it has a what kind of slope? Positive slope, so it's going to be going up from left to right. Where's it going to start from? Negative 1, so it's going to go from negative 1 on the y-axis. It's going to go up 4 over 1. Do they graph that line correctly on all of them, as far as you can tell? No, which one do they not graph it correctly on? Actually, they're all the same for that one, right? All right, so we know D is wrong, but all the rest of them are different by their shading, correct? Yeah. Okay, so let's take a look at, our our first one, what do we typically use for our test plot? What's the easiest thing to use for? 0, 0, right? So if we plugged in 0 for y, we would be saying 0 is less than 2, right? Okay, is that correct? Yeah. So I would be shading to the left of that line, right? All right, so to the left of the dotted line, I want to shade. Is there any of them that don't do that? Does C do that? No, C shades to the right of it. Okay, so we know that C is wrong, right? So does B, and we've already eliminated D, right? So A we would know is our answer, correct? All right, but let's go ahead and look. Is 0 greater than or equal to negative 1? Yes. So on our solid line, we would include 0, 0. So we would shade also to the left of it. Does that work? Yes. Okay. So we know that 0, 0 is in the darkest shaded line, or in the shaded section. So do we see how we get that darkest area? Okay. That's where the overlap of the shading exists at. Does this make some sense to us? We understand the process. You know, we're going to take this kind of just one step at a time. All right, we can look at another one. All right, let's see. So on our first one, we have y is less than or equal to negative 3x plus 5. On that first one, what do we know about the line? It's solid because it's got an equal to. Where does it start from? 5, and then what does it do from 5? It goes down 3 over 1. Do all of them do that? Do all of our graphs do that for that line? Yeah. Okay. All right. So we'll come back to the shading here in a second. All right. Let's go to the next one. What kind of line is it going to be? Solid. All right. Where's it going to start from? On the y-axis, and it's going to go down 3 over 1. Okay, do they all do that? Okay, and we notice that those two lines are parallel because they have the same slope but different y-intercepts. Now let's go back to our shading. We want to use 0, 0, right, for our first one? Okay, is 0 less than or equal to 5? 0 is less than 5? Yeah, okay. 0 is less than 5. So which side are we going to shade? Are we going to shade the left side or the right side? Left, because we want to include 0, 0. All right. Is there any graph in here that does not do that? A doesn't do that. What else doesn't do that? B doesn't do that. Okay. So we're kind of narrowing it down to C or D, correct? Okay. Let's look at the next line. All right, is 0 greater than or equal to 3? No, so it should not include 0, 0 on that part, right? So you're looking at this line right here, the second one, the closest, and should I be shading to the left of it or to the right of it? To the right of it. So my overlap should be where? In between them, yes. Okay, because it's going in opposite directions. I should get D for an answer. Does that make sense? All right, now I'm going to show you something. So you want to pay close attention, especially if you've got a graphing calculator. If you don't have a graphing calculator, you want to grab one. All right, I want to show you how you can test your answer. Okay? All right, so I'm going to come into y equals. Right, and I'm going to put in negative 3x plus 5. I'm going to come down here. I'm going to plug in negative 3x plus 3. Okay, but I want my graphs to shade. So I'm going to come over here. I'm going to go all the way to the left. You see how it's kind of blinking? Yeah. Okay, now notice how here it says less than, correct? Yeah, so I'm going to hit enter. That, you see how it's blinking like that? That means greater than because it's up above the line. You see that? Okay, but I want less than. So I'm going to hit this. All right, does that make sense? All right, now I'm going to come down. Now the other one I want to be greater than. So I'm going to hit enter. No, I don't want that. I want this. Okay? Now I'm going to hit graph. All right, do you see how the darkest shaded region is right there? Yeah. All right, so did you see how it did that work for me? Yeah. All right, so that's how I'm going to test my answer. Okay? All right, so are we learning some new calculator skills that we didn't know before? Yeah. Didn't know our calculator did some of these things? And some of your more advanced calculators can do, can probably even do dotted lines and solid lines and different colors and things of that nature, and maybe even make it look quite a bit better. All right. Let's see. We have some of these. I think that we understand kind of what we're doing here. All right. Let's take a look at, let's say number 4. Determine whether these points are solutions to the linear inequalities. All right. So notice here it just has an x value, right? So in these coordinates, which coordinates am I actually going to plug in? What parts of the coordinates am I going to plug in to test for x is greater than? 14. I'm going to plug in 14, 19, and 17, right? All right, are all those numbers greater than or equal to 9? All right, so it appears that all of those would be solutions, correct? All right, then I would have to go down here, and what would I really want to do with that equation, with the second equation? I could plug in the x and the y's, right, and see if they're less than 4. Okay, so you guys are doing that. So what's negative 4 times 14 plus 2 times 25? Negative 6. Okay, so that's the first one. So that's going to be less than 4, right? What did you say?
Yes.
Yes. Yeah, you said negative 6, right? Yeah. Negative 6 is less than 4. Let's do negative 4 times 19 plus 2 times 32. Negative 12. Okay, is negative 12 less than 4? Yes. Okay, let's try the other one. Let's negative 4 times 17 plus 2 times 35. Sorry, do the whole thing. 2. Is 2 less than 4? All right. No? Yes? Yes? No? What? 2 is less than 4, isn't it? Oh, okay. So are all 3 of those coordinates solutions to that system? Yeah, because they're all, they complete or they answer, they fit as solutions for both linear inequalities. What question was that? 4. If I remember right, I don't find problems very often. But I do have a problem here because I am confident that all 3 of those are solutions. So I'm not too worried about that. All right, let's go and let's look at a couple of questions from your actual homework. Can we do that? All right, lesson 43? All right, you've got A through F?
Yeah.
All right. What one do you want? Everybody wants the word problems, right? All right, but we're gonna do it. All right, but we're gonna do it together. I'm not gonna just do it for you, okay? So it says 2 of the ticket prices for a major baseball game are $65 for a tier box MVP seat, $12 for a bleacher seat. So suppose you want to buy tickets for some of your friends. You decide to buy up to 20 tickets and to spend up to $500. We're going to let X represent number of MVP seats, Y represent the number of bleacher seats. We want to write and graph a system of linear inequalities to represent all the possible combinations of tier box MVP seats and bleacher seats that we could buy. All right, so we need to write 2 inequality equations, right? So the real simple one is, let's talk about the number of tickets that we have. How many tickets are we going to buy? 20. Now, read it again. It says you decide to buy what? Up to 20. So can I buy more than 20? Could I buy exactly 20? Could I buy less than 20? All right, so let's talk about this 20. What's the inequality symbol here? less than or equal to 20. Okay? So if X represents MVP seats and Y represents bleacher seats, what inequality am I going to write there? Let you think about it for a second. We're just talking about number of tickets. Think about it. Yeah. No, you're trying to include cost now. We're not including cost yet. It's real simple. I think you guys are overcomplicating it. Could I buy, what's that? Perfect. X plus Y, right? Because I could buy one of each, right? So I could start off with X. I could even buy 0, correct? So that's my first one. This is just talking about strictly the number of tickets that we're buying. Now we're going to talk about the cost, right? We're going to write a completely separate equation for the cost. All right, what is the cost of those MVP seats? So how am I going to represent that in my next equation? 65x. And what about my bleacher seats? So how am I going to write that? Plus 12y. Okay, and remember this is cost. How much money am I willing to spend? 500. I'm willing to spend $500, but am I willing to spend over $500? Am I willing to spend exactly $500? Am I willing to spend less than $500? So what kind of inequality am I going to write? Less than or equal to $500. Okay? All right. So now I can begin to actually draw a picture for this, right? All right, we could have a chart here, okay, where this is my y-axis and this is my x-axis. Now, what is my y-axis actually representing? No, what does it actually represent? What does y represent here?
Bleacher seats. Number of
Bleacher seats. Okay, what does x represent? MVP seats. Okay. All right, we want to go, up by a certain amount. Notice that, what numbers could I go by to include all these different things? I could go by 5s. Okay, so we start 5, 10, 15, 20, 25, 30, 35 if we had to. You want to go by 5s down here too? 10s? I would keep it apples to apples, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. When you go 65, right? Something like that. All right. Now, but if I'm going to write this, would it be easier to write these equations again, but in slope-intercept form? All right, so what would that look like, say, for x plus y is less than or equal to 20? Okay. All right, so we could have something like that. All right, so if I was going to go ahead and graph that, right, that would give me, positive 20. Right, so we got that here. And my slope is down 1 over 1, right? Yeah. Or down 5 over 5? Yeah. So down 1 over 5, down 1 over 5, down 1 over 5, down 1 over 5. So I'd come to about there, right? 5, 10, 15, 20. Right? And I'd be from here to here. Something like that. Okay, that looks okay. Maybe. Okay. All right, now let's talk about our shading for that. So let's talk about this. Is 0 plus 0 less than 20? So, okay, so would we be shading to the left or to the right? Okay, all right. All right, that looks fine. All right, let's look at our next one. Let's see, so this would be 12y is less than or equal to negative 65x plus 500, right? Okay, but then we'd have to do what there? Divide by 12. So y is less than or equal to, what's negative 65 divided by 12? Probably doesn't come out to, just give me the decimal.
Oh, the decimal is
Negative 5.4x. And what's 500 divided by 12? 41.6. Okay, so we get something like, oh, we actually have to go up a little bit further, don't we? 40, 45. So we're actually looking at like here, right? Right, and going down, you know, negative 5 over 4. So we may actually even have to find our x-intercept, right? Do we remember how to find an x-intercept? Set y equal to 0. So we would take 500 divided by 65, correct? What's 500 divided by 65? 0.76. 7.69. So 7.69. So about right in here, correct? So something like that. Okay. Now let's look at this real quick. 0, 0. Is 0 less than or equal to 500? Yeah, so I'm shading to the left, correct? So my darkest shaded region, I'm going to just pick a different color, is going to be right in here. So anything in this green area is going to fit both scenarios, correct?
Yeah.
Okay, anything outside of that would fit maybe one, but not both. Okay, so my number of tickets are going to be right in here. Okay? All right. So do we understand F? How to start it, how to work through it, how to graph it, and how to finish it. Okay? All right, if you guys can do that, you should be able to do all the rest of them, correct? All right, so I'm going to stop right here, give you guys time to work.